All right, this is going to page 62 when we are done. So exponential growth and decay. So the first thing is, I want you to look at these calculators. Should have said this to begin with. We've talked about these a little bit, but turn it on, and then we're going to talk about how to clear it and how to make sure it's in the right mode, and so that, you know, in case anything weird happens. But see the shift key on the top left? Hit shift 9, because that's where clear is. Then you can follow the thing. You're going to do 3 for all, then equals for yes, and then AC makes it all cleared. Okay, which there may not have even anything to clear in there, but again, it kind of resets everything back. Up at the top, the little things that are up there, there should be a little tiny D or an R for degrees or radians. Right now, that doesn't matter either way in what we're doing. But then it should also say math. That may seem ridiculous, but you need to make sure it says math, because if it doesn't, then some of these things in here function differently, and you want it to just do the basic stuff, like if the fractions won't work right and whatever, and that's one of the things that makes this calculator so beautiful. All right, so we'll need this in just a minute, so just put it down there. All right, so we got exponential growth. Growth occurs when a quantity exponentially increases. Exponential decay occurs when a quantity exponentially decreases. Right? I know, it's like crazy there. So here's what the exponential growth function looks like. F of t is equal to a times 1 plus r to the t power. Okay? So that's an exponential, just like what we looked at yesterday, right? The a is the stretch, and yeah, and it's an interest formulas that I know that these are not new to you. Then 1 plus r, and then t stands for what? Time. Okay. So then exponential decay, f of t, is equal to a times 1 minus r to the t power. Okay, so a is the initial amount, r is the growth or decay rate as a decimal, and t is the length of time. All right, so let's look at number 1. It says Brooke started her career with an annual salary of $32,000. We're going to assume that's dollars because I left that off. Each year thereafter, her salary increased by 2.5%. Write and use an exponential growth function to find her salary when she retires after 30 years. All right, so it's an exponential increase. You would hope so, or she's got a really bad job, right? And so this is going to be f of t is equal to her initial salary was $32,000 times 1 plus, what's the rate? 0.025, good, to the t power. That's what has to be written first, because look at what this question says. It says, write and use a formula. So that's us writing it, right? And then we can substitute in t and see what happens. Then us using it is substituting in what for t? 30. And then that's equal to 32,000 times, well, 1 plus 0.25 is 1.025. I mean, you could leave it as plus, it doesn't matter, to the 30th power. Okay. One thing you got to pay attention, because these are easy and these are not new, and I know that, is that when it says annual, so we got an annual salary each year after, and find the salary when she retires after 30 years. Like, you want to make sure those units are all the same, so you're not having to do anything weird there. All right, so then you can go ahead right now, just type that in your calculator, just like that. You don't have to use the multiply sign. You can just put the parentheses there. The exponent key is the x with the little box at the top. You put the little 30 in. You should be able to make it look exactly like it does right here. Then when you answer the question, you can't just put a number. You have to answer the question and say something like, Brooke's salary when she retires after 30 years is this amount, right? And, you know, however you write your sentence, just make sure you have the right pieces in there. And it's, what'd you get, $67,122.16. There you go. That's how, yeah, she increased to that amount. So along the way, she was making more and more and more and more. All right. So 3 parts to each of these answers. Pay attention to that, because if you're missing a part, I'm not giving you any partial credit at all. You have to write the formula, then you have to use the formula, then you have to answer the question, right? It's not that hard. This is pretty easy. Make sure you have all 3 parts. All right, so then number 2. In 1995, a magazine had 14,000 subscribers. The number of subscribers increased by 40% each year thereafter. Write and use an exponential growth function to find the number of subscribers in 2016. All right, so then we're going to have f of t is equal to, we start with 14,000. Then we're going to multiply that by 1 plus what? 0.4 r, yes, which is 0.4 to the t power. So that's us writing the formula. Then we substitute in. What are we going to substitute in for t, do you think? The years. 21. All right, and it says we got year and year and year, so we're good. So if you do 2016 minus 1995. All right, so you get f of 21 is equal to 14,000 times 1.4. Oh, that's a 5. My goodness. 1.4 to the 21st power. Is it a pretty big number? Okay, so this 40%, the trend of how much it's increasing, it's not like they decide that in 95. I mean, they may be hopeful, but they don't know what's really going to happen. But let's say like in, 2008, they say, you know what, this is what's been happening. We are increasing by 40% every year. So let's predict what we're going to be at in 2016. And what did we get? 16,398,978. You can't have part of a person, right? So the way you think about this is, let's say that 35.2 people fit on a bus. How many people actually fit on the bus? 35. So this is a time where you round down. Even if it's 32.9 people, you round down to 32 because you can't get that 33rd person on there. Make sense? We're talking people. We don't do parts of people. Huh? Yeah, or maybe a tiny person, a child. All right. So they in 2009 they're saying, okay, let's predict this. So they predict this. We're going to have 16 million in 2016. Well, it's a prediction, right? Are there things that could affect that actual number? Absolutely. And chances are pretty good if that is what they predicted in 2009, they were probably wrong because of technology and everything else, right? How many of you have magazine subscriptions? Anybody? Yeah, me either. Well, I sort of do. I have People magazine coming all of a sudden. I don't know. I never subscribed. I don't pay for it. I don't know why it's coming, but it has my name on it. I can't cancel it because I don't have an account, so I don't really know what's happening. But anyway, but nobody does that anymore, right? And you could subscribe online, but you can usually find it free online too. So, it's a prediction, right? All right. But I want you to think about, like, we do this 1 plus 0.4. So what is that 1.4? What is 1.4 as a percent? As a percent? 140%? Be 140%, right? Yeah. Okay. So let's say that I gave y'all each 1 eraser when you came in, but let's say that I gave you 30 erasers, right? Wouldn't that be exciting? It would be a great day. So I give you 30 erasers, but then next period I'm going to give them 20% more, okay? I know, doesn't seem fair, does it? So you could find 20% of 30, and then you could add it to 30, right? And that's when you learn percents, that's basically what you're learning to do, right? But it's also, they're going to get 120% the amount of erasers y'all got, right? Because they get over 100% of what you got. So when you do this, and let's say we multiply this times 1 plus 0.2, if you distribute, that's what's happening here. That's how, like when you first learn them, 30 times 20% is going to give you 6, and then you add it to the original. Well, that's where you get 30 plus 6 from, and then you just get 36. So if you just do 30 times 1 point, or 120% or 1.2, you're going to get your 36 in one fell swoop. So when you're trying to figure out tax on something, Okay, this is just a little side note of a life lesson. You have a total of something. You want the amount of tax. Yes, you could calculate the tax and you could add it back. But if you have a calculator that doesn't save things, then you've got to remember what it was and if it was accurate or whatever. But the tax rate in most places around here is 8 1/4. So if you just take whatever your total is, let's say we spent $32 on something. So instead of finding the tax and adding it back, if you just multiply that by 1.0825, that gives you your total with tax. Do we know those things? Know how to handle them? Because you got to know if you have enough money for something, right? Whether it's the amount of money in your pocket or the amount of money in your bank. And if you're not having to worry about that yet, you're going to soon, all right? Especially if you're in college, okay? My daughter, I look at her bank account every day, and I don't even know how she eats. I'm a little worried, but sometimes there's like $1.75 in her checking account. But let me tell you, she knows exactly how much she can spend when she pulls that credit card out. If she can get her gas or if she can do whatever. I don't let her starve, by the way, but she just needs to learn to save her money. Stay out of Target, and she'll be okay. So let's talk about reducing things. Let's talk about we found something on sale, right? So there's something that costs $32, and it's 75% off. Those are exciting. I love 75% off sales. Like, woo. All right, so I stand in the store sometimes when I'm shopping, and I hear people talking about, like, okay, this is 75% off, or this is 40% off, so how much would that be? And they have this deep conversation, and neither one of them have a freaking clue how much it would be. And like then they estimate, and it makes me like sad, and I'll try not to laugh. And then they pull out they'll even pull out a calculator, and they calculate it wrong, and I'm just like, whatever, they can figure it out when they get the checkout stand. But I personally get a little insulted when there's those little signs that tell you how much it is. It's a 50% off sale. Here's what it would cost. I mean, come on. You got to know how to function, right? So if it's 75% off, you could find 75% of 32 and then subtract it, right? Absolutely nothing wrong with that. But do you really care how much you're saving? Well, you do, ladies, when you get home and you tell your husband, it was on sale, I saved all this money. You don't really tell him how much you paid, you tell him how much you saved. But anyway, but you really want to know how much it's going to cost. Like, do I have enough money? Is it a good deal? Whatever. So don't think about what you're saving. What are you paying? So if it's 75% off, what are you paying? What percent are you paying? 25%. So all you really care about is what's 25% of 32. Make sense? And when it's something like that, 25% is a fourth, right? So you could just divide that by 4, and it is $8. It should be kind of easy to figure out, depending on what it is. Let's say that it was 40% off, okay? So if it's 40% off, what are you really paying? 60%, right? So if you're going to use your calculator, which is fine, everybody can pull it out on our phones. Sometimes I estimate in my head, sometimes I pull it out and do it on the phone if I need to know exactly what it is, if it's really better or whatever. But basically, you can take 32 and multiply it by 0.6, okay? And that will give you the actual whatever you're paying. But if you just want to estimate in your head, and sometimes they're easier to estimate than others. Yeah, it's a little bit more than a half, so it's a little bit more than $16, but maybe you need a little bit better of an estimation. You can always find 10% easily. What is 10% of 32? 3.2. You literally just move the decimal place, right? So it's a little bit more than $3. So, but it's 60% that I want. So 6 times 3 is a little 18, so this would be a little bit more than $18. 19.2. But if all you really need to know is it's a little bit more than $18, okay, yeah, I got that, whatever. If you really need to know, you can pull out your calculator or you can do it in your head. Some of them are easier to estimate exactly, but know how to do those things for a couple of reasons. So that you don't look like a fool when you get up there and you don't have enough money. So that you don't get ripped off at the checkout when something doesn't ring up right, because they don't ring up right like a lot. And trust me when I tell you, when you try and correct somebody at the checkout, they don't have a clue how to figure that out either. It's really kind of sad. I've taught a lot of math at the checkouts before, but it's I know it's scary, but you got to be able to function. Okay, so that's a little side note on percentages and how to handle yourself out in the real world. All right, so now Kate drank an energy beverage with 150 milligrams of caffeine. Each hour, the amount of caffeine in her system decreases by about 12%. Write and use an exponential decay function, blah, 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 amount of caffeine in her system after 8 hours. So we're talking about hours and hours, so we're good. So I do F of T. That's equal to, what do we start with? 150 times 1 what? Minus 0.12 to the T power. Okay, because it's a decay, so you got to go down. So F of what? 8. Good. That's equal to 150. And, oops, times, what's 1 minus 0.12? What's $1 minus 12 cents? 88 cents. Okay. Don't make it harder than it is, to the 8th power. Then we just type that in, and you can say that Kate will have blank milligrams of caffeine in her system after 8 hours. All right. Oh, I guess it's kind of a good point. But just because you're somewhere where you're making change doesn't mean that you're an idiot either. Let's be clear on that. Yeah. You're insulting Parker over here. All right. Kate will have 53. How many decimal places should we go to? 3. Always 3 decimal places. That's an AP thing, unless you're an AP or AP stats, and then it's 4. But it's 3. The reason we went to 2 on the other one is because it's money, right? It's money, and then people, we don't do that. So, but 3 decimal places, unless it states otherwise, which it did not. Okay. All right. Are we good so far? All right. Let's look at the next one. So it says the half-life of mercury 197 is 3 days. So we got a half-life, mercury 197, 3 days. Write and use an exponential decay, that kind of gives it away, to find the amount of mercury 197 left from a 50 milligram sample after 20 days. All right, does the 197 have anything to do with what we're about to do? No, that's part of the name, right? Yeah, so it's just mercury 197. It's not like we incorporate that at all. Yeah, just to confuse you. So we're going to do F of T, right? That's equal to, what did we start with? No, we started with 50. Yeah, started with 50. Times 1 minus, all right, so what's the rate here? Half-life, 0.5. 1 minus 0.5 to the T power, right? Sort of. T stands for what in this? I mean, it's time, but specifically on here, what does it represent? Days. Okay. Does this get divided in half every single day? No. It says it's 3 days, right? So am I going to multiply or am I going to divide?
Oh no, you divide it because it's a month.
So let's say we have 30 days. In 30 days, how many times does it get divided in half? 10, because it's every 3 days, right? So we basically would have to take that 30 and divide by 3. So if it's not happening every single day, if it's happening, less than every single day, then you're going to divide by 3. If it was happening 3 times a day, that's when you would multiply. Does that make sense? So if it's happening 3 times a day, you do 3 times T. This is T divided by 3. Okay? So some of you may fully understand that, depending on the sciences if you've had, and like that's a no-brainer, but some of you may need to reason through that, and that's okay. All right, so now what is T? 20. So T is 20. So we get F of 20 is equal to 50. What's 1 minus 0.5? 0.5. Okay. To the 20 over 3 power. So here's what I want you to do when you type it in. When you get to the exponent part, when you're in the exponent, hit the fraction key, which is on the far left under recall, and then literally put 20 over 3 so it looks exactly like what you have up there. You'll get the same answer if you do 20 divided by 3, but I just want you to see how you can, manipulate this thing. If you're having trouble with calculator things, let me know. I'm not going to put it up on the document camera. You arrow down. You do it's the big oval button. All right, and how many decimal places should we go to? 3. So point what? Come in. Point what? 492 what? Grams. Okay, what questions do you have on this? Are we good? Okay, flip it over. So that was exponential growth and decay. Now we have continuous growth and decay. When you're talking about something continually changing, then that should just basically scream at you that it's going to be a formula that has E in it. And tomorrow we'll watch a little video and I'll explain to you kind of where E came from. I know since it's not brand new to you, you've been using it, but you don't have a clue why or anything, and that's okay. We're just still not going to have a clue today. right, so it says sometimes a quantity is constantly increasing or decreasing at an exponential rate, and not just after each year, month, day, hour, etc. So, like for your for a salary, every year, if you get a raise, you boom, your salary just automatically changes. It's not like it changes by a few pennies every day or anything like that. That would be nice, but no, that doesn't happen. It is like a boom, it just happens. So this is what's called your PERCH formula. So A is equal to capital P times E to the RT formula. Again, shouldn't be brand new to you. You've seen this at some point in one of your math classes. But it says the formula to the right can be used to find the balance of the account. So I really should have, it's not balance of the account because we're not always talking about money. And we'll look at some where we're not talking about money. The key here is this. R, your rate, is positive for growth and negative for decay, which is the same thing happened on the other one. We just don't think about it that way. If you look back at what we had over here, see how we have a positive R and a negative R? We just thought about it as addition and subtraction, but it's the same thing. R is either positive for growth or it's negative for decay. So we're not talking about a bank account because this would be the most disgusting bank account ever, but a garbage dumpster started with 4 pounds of garbage. Okay, so we start with 4 pounds of garbage. The amount of garbage increased continuously by 35% each day from this point forward. Find the amount of garbage in the dumpster after 2 weeks. Okay. So A is 4 pounds because that's what we're starting with. Okay. No, not A. No. P. P is your principal. The capital A, it means amount. Why this isn't written if this is a function, I don't know. But you have A is equal to what your principal is, what you're starting with, and that is your 4 pounds of garbage, times E to the rate is 0.35 times T. Okay. So what is T here? 14, because it says 35% each day. This is what defines what your T is, 35% each day. But we want to know after 2 weeks. So that's 14 days. So I do A equals 4 times E to the 0.35 times 14 power. Because the instructions are to write an equation, then use an equation. Those are two completely different things. Because this is my equation, so if I want to know what is it after 3 weeks, 4 weeks, 5 weeks, I just keep going back to that. Okay. All right, so then you just type that in, and you get, there will be a garbage. I didn't see it, but I felt it. I know. We went from really hot to really cold, like we can't have it in between. I know. Isn't that rude? Okay. So we have, did you get 537.159 pounds? Make sure that you have the units on there. And make sure you're not just copying down my numbers, that you're typing them in. I really think that you are smart enough to use a calculator, but just make sure. Is that something that maybe somebody needs to know? Maybe the garbage dump people, like they need to know how often do they need to come and dump this dumpster? How often, how many, a single truck can go pick up how many dumpsters because it can only hold so much. When do they have to come back? Things like that. So that's definitely something that, a garbage company would need to know. All right, so then let's look at number 6. What'd you do? Delete. All right, so the population of a town is declining, at a continuous, that means we're going to use the E, rate of 1.5%. Current population is 16,000 people. Find the population in 8 years. Okay, so we have A is equal to, we start with 16,000 times E, the rate is 0.015 times T. So is that a good formula for that? Looks like it. Does it have to be negative? Why would it be negative? Because it's declining. Yes, it absolutely should be negative. So I was waiting for somebody to tell me that. Now, had I not put that on there and we went all through it, the answer you get would be bigger than 16,000. Should you then say, something has to be wrong? Yeah, you should, because it clearly says that it's declining. So it should be negative. So then A is equal to 16,000 times e to the negative 0.015 times 8. We can say population after 8 years will be this is what I got. Because remember, you cannot have part of a person. No, it's a comma. All right, what questions do you have? Anything? Okay. I mean, these are pretty much plug and chug problems. Like, here's your formula, plug the stuff in. Just make sure you're reading it correctly and that you're getting the right stuff substituted in. All right, so then we have logistic growth. So have you ever heard, maybe you know somebody, or maybe you've like heard it in a movie, and like, what do you do? Oh, I work in logistics. Like, that's a thing, okay? That means basically you work with numbers, and you are helping companies maybe save millions or figure things out. Like, it's all about the math that goes behind it. Now, well, do these people have computers that help them? Absolutely. But the people that are making the big bucks doing that and getting degrees in that also understand what's happening behind it. Like, they actually understand the math, not that they can just punch it in and get a number, okay? Logistics is pretty, it's a little complicated to figure out. So I'm pretty much giving you the formulas. We're just going to talk about it's an exponential type of thing. So it says sometimes a quantity exponential, and this should say exponentially, increases, but then levels out, approaching a horizontal asymptote. This is called a logistic growth model. The logistic growth function is given as this. So the asymptote is c, y equals c. So that's where you have to level out at. Like, you're not going to get any more than that. We'll talk about why that is what it is. And then we can substitute the rest in. So it says a disease begins to spread in a town of 20,000 people. After T days, the number of people who have been infected by the disease is modeled by the function below. Using the function, find the number of people infected after 10 days. So we have to know what our asymptote would be, which would have to be 20,000 people, right? It cannot exponentially increase forever, because if there's only 20,000 people, you're not going to infect 30,000 people. There aren't those people there, okay? So that's how we know what that C is right there. And then the rest says, it just blah, 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 blah. After T days, the number of people who have been infected by the disease is modeled by this function. Using the function, which was already written for you, find the number of people infected after 10 days. Okay, and so this says after T days, so we're good with the units here. So I substitute in, I'm going to do F of 10, that's equal to 20,000 over 1 plus 1150 times E to the negative 0.95 times 10. So when you do this, when you type this in, you can either start with the fraction button, or you can type in 20,000 and then hit the fraction button. Then you can put all of that stuff in the denominator, and this is one of the things that makes these calculators so beautiful. Okay, so use the fraction function for this. Let me know if you're having issues figuring out where the buttons are or anything. Because, well, I am not going to teach you logistics because we don't have time for that, but this is the formula that you're using. Okay, so you have to, this is the limit, basically. Well, C is where your asymptote's going to be. You can't get any higher or lower than whatever that is. Okay, so if you look at that function there. So then, to write this out, we would say blank number of people will be infected after 10 days. Okay. So how many people did we get? 18,000. If you got 20,000, I want to see what you typed in. Yes, because you did not listen to what I said. So you didn't use the fraction function, and that's why you have it wrong. So when you do 20,000 divided by this, and that's literally what you do, 20,000 divided by this, you do 20,000 divided by 1, and then you add this to it. And then essentially this ends up being very, very, very close to 0. depending on whatever it is that you have. So yes, if you got 20,000, it's because you didn't listen to what I said. So 18,414 people. Would this be a pretty scary place to live? Yes. I mean, there's only 20,000 people after 10 days. That's like a continual thing. It's not like, oh, today, they might say today 5 more people were affected and tomorrow 5 more people are affected, but it's not really like 1 per day or whatever. But it's continually. That's the thing here. It is exponential, but it's continual. So that, yes, you could walk into class here and we can infect a couple people, then we walk into another classroom and, and it just kind of, continuously is happening. It doesn't happen like at 12 o'clock every day or something like that. All right. So then we have the population. So then read number 8. Go ahead and work on this one on your own while I hand out the assignment. Mm-hmm. Mm-hmm. All right, so what number do we substitute in? 70. Mm-hmm. But is your answer weird? Yeah, what'd you get? 12? It's what? 12 million. The population in millions. So it is 12.185 million. Mm-hmm. Oh, what that means is what I can substitute in a number anywhere from, basically we have data from 1850 to 2000. So this function represents any of that. If I want to figure out the number of years since 1850, if I want to figure out the population in 2010, I don't get to use this function because it'll only work up until 2000. Does that make sense? That's what that means there. And the other thing is, here my horizontal asymptote is at 135. 135 is not in that question anywhere, is it? But still, there has to be some sort of limit, and that number can be based on a lot of things. It can be based on, how many total people are even in the, in the world, or based on those logistic growth models, just how many people are, what does the world's population increase as every single year, and then that's going to affect whatever your limit is here. There's got to be some sort of something to figure that out. But nothing you'd be expected to figure out. That's why this is pretty much just given to you. Okay? What questions? Do you have anything? Are we good? Awesome.